And you see that this I told you in the beginning itself, class A amplifiers are very highly linear and class B amplifiers are non-linear. Non-linear means you see here, when you give sinusoidal or cos voltage, not only this current is amplified, the harmonics of this current is also amplified. What do you mean by harmonics? You see here, IC plus B naught plus B1 cos omega t is your component. Cos 2 omega t, cos 3 omega t. See, this term is highly unwanted for you. I need only omega t, but other than omega t, you see, you get 2 omega t, 3 omega t, high frequency components you get. So, which are all called as harmonics. They are called by the name HARMONICS. They are called as harmonics. Harmonics means they are integer multiples of the fundamental frequency. The fundamental frequency is omega. So if you multiply this omega by integer, what will you get? 1 omega, 2 omega, 3 omega, 4 omega, right? So except 1 omega, all the other integer multiples of your frequency, 2 omega, 3 omega, 4 omega, are all called as harmonics, and they have represented by constants. B2 will indicate 2 omega, B3 will indicate 3 omega, B4 will indicate 4 omega, B1 will indicate omega, B0 is your constant term. So this is because of the non-linearity of your transistor, and this non-linearity is not present in class A. It is present only in class B because the transistor is biased at cutoff condition. Okay, and you know that for a given time the base currents are out of phase. For a negative half cycle, for a positive half cycle, base 1 is positive and base 2 is negative. For negative half cycle, base 1 is negative and base 2 is positive. So I can write the base currents as negative of each other. So IB2 equal to minus IB1. And IB1, I know it is IB1 is IBM cos omega t. And instead of minus sign, I can write cos 180 plus theta. You know, cos 180 plus theta is minus 1. So instead of having the minus sign, I'm writing this minus sign as an angle. So IBM cos omega t plus pi. So you can see one base current and other base current are out of phase by 180 degrees. So the base current are out of phase by 180 degrees. The collector currents are out of phase by 180 degrees. So when you substitute here, the output current will be given by, you have to substitute this there in this equation. So I2 will be equal to, you see, I2 is equal to I1 into omega t plus pi. So wherever you have omega t, you have to replace omega t plus pi. So see here, I naught plus B naught plus B1 cos omega t. Omega t should be replaced by omega t plus pi. B2 cos 2 omega t. The B2 cos 2 into, replace omega t by omega t plus phi. B3 cos 3 omega t. B3 cos 3 into 3 omega t plus phi plus etc.